Hello. Hörs jag? Ja, nu hörs jag. Bra. Då ska vi fästa den här igen. All right. I think it's 10 past, so we're going to get started here. Welcome to this session. We're going to talk about security and authentication, a topic that I know you're all very passionate about. So when it comes to security in recent years, we've seen headlines like this, where Mercedes-Benz this spring accidentally leaked a password that exposed their source code. We had last year SourceGraph that was breached from a leaked admin access token. We had Uber 2 years ago, where someone had left credentials in a PowerShell script that led to their entire cloud environment getting owned. Starbucks left API keys in a public repo, and even Microsoft this year, or kind of last year, depending on which article you read and how far you want to dig into it, had a test account and a test tenant that was able to escalate its way all the way to email boxes for management. And all of this, among other things, led to Microsoft, of course, going out and saying that we're prioritizing security above all else. And when it comes to security, identity is the new perimeter. This might be something you've heard. Also more headlines like this. When it comes to our network, protecting our network, identity is the new perimeter. This means that when we're in the cloud and modern development and modern platforms, everything is kind of public by default. So to protect ourselves, we need to be able to trust that you who are trying to access our stuff is who you are who you say that you are. And that's why identity is the new perimeter. And you might have seen these. So identity is the new perimeter. Why is it so hard to defend? Well, it's complicated. That's why. My name is Emanuel. I work as a cloud specialist at Unwanted here in Sweden. We are expert consultants within Azure and cloud environments, do everything from DevOps code environments to platform deliveries with Azure Landing Zone, stuff like that, and educational things. And I love doing everything as code. So wherever possible, I try to write infrastructure as code, config as code, and of course, normal programming as well. I do a lot of PowerShell modules and tools for working with Azure mostly, and most of them are open source, which I'm a big fan of. I have a blog called pipe.how, and I roast coffee, I play Dungeons & Dragons, and I play disc golf in the summers. This is me. You can all find me online at Palm Emanuel on GitHub or X or LinkedIn, wherever you want to talk, or offstage afterwards. Microsoft releases this fun report called the State of Cloud Permissions Risks Report, which is something you don't want to say 10 times fast, where this 2023 edition, which I got hold of in May, I think, had some fun numbers. So I think we're gonna play a bit of a guessing game here together. Out of all permissions across all clouds, this is AWS, Google Cloud, Azure, I think Alibaba is in there. How many permissions do you think exist? Like individual permissions, like read, write on this specific thing. Any guesses? 100,000? 2 billion, that's a good guess. A bit. No. We actually have about 40,000. This is when I wrote the presentation, so it's probably like 1 billion now. Next one then. Also to note there, above more than half of these are categorized as high risk, which means that if you get a hold of them and you want to do something really bad, you probably can, and can cause catastrophic damage, is the definition they use. We have a lot of identities these days that aren't human identities, right? So how many do you think workload identities do we have per human account? So for every email account or my organizational account, how many workload identities, this is like service principals and managed identities and service accounts, do you think there are? 7. It's a good guess, 7. We have about 10 for every human, which means that when we're talking on and offboarding for our employees, we need to be about 10 times as strict with whoever like onboards or creates these applications or make sure that there are no secrets lying around or API keys. Next, we have a fun one, I think. What is the percentage of all granted permissions that you think are actually used? 1%. You're right. That's how bad it is. So out of all permissions that we grant our identities, this is human and not, we are using about 1% of those permissions, which means that we're over-privileging our identities by a factor of 100. How many of these identities do you think are super admins, being able to take control over part of or an entire cloud environment? 90%? 5%. So somewhere in the middle. We have about a bit over half of these being able to escalate their way to control a large part of our environment. And then finally, how many of these do you think are inactive, not having been used for 90 days, at least? 19? 90? 90? About 60. So this is the state of cloud permissions today. Welcome to the session. We're going to talk about identity types. What types do we have in Azure? What are the differences between humans and other types of identities? We're going to talk about credentials. What options do we have as developers maybe when we want to authenticate as an application? We are going to talk about applications and resources in an OAuth sense, and how to grant permissions and define scopes for tokens. We're talking about tokens as well, and a few examples of auth flows. And then finally, we have a summary at the end. But as I wrote this presentation, I figured that if you have a question that you're kind of holding on in the start on identity types, like 35 minutes later, you might be a little bit like forgot it or something. So instead of doing questions at the end, let's switch it up and like raise your hand or interrupt me, preferably not too promptly, but and then let's have some discussion about it. And then lunch with more discussion. Sound good? Awesome. So identity types in Azure. We have two main identity types, which is the human identities, our normal accounts that we log into our computers with for our organization. They're usually tied to an email inbox. And we have machine identities, which is all other identities. This is a category that is split into two, where we have device identities, all our computers, our servers, being able to authenticate as the device to get stuff like patches and stuff from central servers. And then we have workload identities, which is what I want to focus a little bit more about today, because we might not care about the devices as much as developers usually. We, before then, want to talk about, or I want to just get a common understanding about what a workload is. So according to well-architected framework, Microsoft Azure's framework here, a workload is a collection of application resources, data, and supporting infrastructure that function together towards a defined business goal. So this could be a batch script together with all the servers and identities lying around there. It could be a web app, it could be a Kubernetes cluster and all the things going on there. A workload identity, in an Azure sense, is either an application, a service principal, or a managed identity. These are the three workload identity types that there are. And how many of you are using one of these today in Azure? Yeah, most of the room. All right. So some of you might be thinking, what about service accounts? Because we have those, right? We have accounts that have usernames and passwords, and we use them like a service. And that's very common when we work on-prem in AD, for example, or classic systems. In Azure, if you dig deep enough, there are three types of service accounts, which are managed identities, service principals, and user-based service accounts. I would argue that only really the last one is a service account, because the other ones are workload identities, and I would strongly suggest you not to use them unless absolutely necessary, because those are user accounts, but we can't enable multi-factor authentication on them. We can't have like UB keys and cool things like secret, passwordless. Sorry. Whereas for managed identities and service principals, we have more more tools to secure these identities from a non-interactive sense. User accounts are great when you are interactive with something. So workload identity types then. We have 3 different ones, as we said. And let's start with applications and service principals. So applications look like that. Service principals, I've taken the liberty of representing with a user. They're not really looking like that. If you look at in the Azure portal, you might be more familiar with this. They're called app registrations. That is an application that has been registered in your organization. And enterprise applications. These are service principals. And we're going to talk a little bit more about how they work. If you have a tenant, this is your organization maybe, and you want to register an application, you want to use a web app or something where the application itself needs to do some work on its own without anyone interacting with it, then you register an application. When you register an application, you get a service principal for free. Because when this application needs to act within a tenant, it does so through a service principal. So these are connected. And this works really well for a single tenant scenario. You have an app, it does some work on its own, maybe on a timer or like a cron job or something. But then if you have a multi-tenant scenario where I am setting up a SaaS business, for example, we have ServiceNow, we have like any type of cloud provider for a service that does stuff through Azure. This looks more like this. So I present my application to you, and you, either as a user, if you have access, or as an administrator, consent to this application. And when you do, when you consent to this application, you get service principals for this application as well. And this lets our new application that we registered in our tenant, we only have ever one app registration per application. It lets it act in other tenants as well with these identities. Those are 2 of the types. We also mentioned managed identities. These come in 2 flavors that I think are important to keep apart and keep separate because they are very different. We have system-assigned managed identities, which are enabled for a specific resource tied to that lifecycle. So I can say my web app should have an identity. This web app is the only thing that can act as that identity. And when I delete my web app, that identity will be gone. Whereas user-assigned managed identities are instead created as a separate resource in Azure and can be tied to one or multiple resources. This means that it's also separated from the lifecycle of those resources. So you can create an identity, assign privileges or permissions, and then eventually assign it to whatever it needs to do work from. It's the same. If I have it on a web app, that web app can act as that identity. But you should be careful not to kind of use it for too many purposes, because it's very easy to say that, well, we have this user-assigned managed identity which already has access to SharePoint or whatever you're working with, or all the calendars. Let's just add this to our second app over here and our third app over here. And the Kubernetes cluster is doing something similar, so let's use it there. And suddenly you are kind of not keeping tabs on what this identity is used for anymore. And once you want to kind of scale down or start removing stuff from it or decommissioning it, then it's very hard to say, is it even in use anymore? You can check logs and you can do work, but it's much better to have a full governance and the process around it to keep track, especially since we have 10 times as many of these as we have users on average. These are backed by service principals behind the scenes, so they have an identity in Entra ID as well, and that's how it works. And these, as I said, they have the user-assigned ones have a resource in Azure that you connect and attach to a resource like a web app. This means that anyone who has access to that resource in Azure can also possibly attach it to new virtual machines or web apps. We had a I think it was Norway last year, a couple of years ago, where someone had left an identity that was used for testing with very high privileges. It wasn't attached to a resource anymore, but someone was able to create a virtual machine, I think it was, or if they found a virtual machine with where they could attach this and then leak a bunch of data because it still had permissions. Now, quick recap of the 4 types. I consider them different, so 3 categories, 4 types. We have applications which are registered. I'll slow down at the end if you want to take a picture of this. We have applications which are registered in a single tenant but needs service principals to operate in that tenant. We have the service principals which are registered for an application in one tenant. We have the user-assigned managed entities, which are their own resources in Azure and can be connected or attached to one or multiple resources. And then finally, we have system-assigned ones, which are fully managed by an Azure service. And the big difference about the user-assigned and the system-assigned are the life cycle between them, where you can delete the web app that has this, a user-assigned one, but the identity will stay there. Now, talking about authentication, how do we prove our identity as these identities? Well, there are a few different credentials here. We have secrets, which are our classic password for an application. How many here use secrets, client secrets for, yeah, a few of you. How many use them only for developer scenarios and not in production? Great, yeah. So these are passwords for our identities. This is basically a username password scenario for our client app, our identity. This means that this password could leak. It could be copied somewhere. It could be emailed. It could be used from outside our organization, depending on our other security kind of boundaries. Do we have conditional access and stuff? Maybe blocking it, but it means that it's a text string, and it's really easy to get lost somewhere and not keep control over it. So preferably use them only in developer scenarios in like local development or trying stuff. But when you move to your test environment or your production environment, you want to move on to more secure credentials. We have, as a more secure credential, certificates. So these can be installed in a specific source like a VM on your server. And it lets us, by keeping the private key installed together with the certificate, we can upload the public part to our identity, which will let us prove in an authentication way that we are the owner of this identity. And it's much, much harder to accidentally get a certificate lost somewhere on the internet compared to a string that you can copy. And then finally, the more exciting one, I think, is a federated credential. This lets us trust between Entra ID for our identity and other platforms such as GitHub, Azure DevOps, which is technically its separate identity provider, Kubernetes, if you enable OpenID Connect in there, even Google Cloud or other platforms that implement OpenID Connect as an extension of OAuth 2 can use this identity. And this makes it so that Entra and this other platform does a token exchange, like a handshake initially, and then they will trust each other's identity tokens. So if I have a pipeline in GitHub, for example, that pipeline can get an ID token for itself, can send that over to Azure, and if this is configured correctly, we can say that this main branch in this repository in GitHub can use this identity in Azure or in Entra based on this credential configured. And this is really neat. Then we have a couple of different ways of these being supported. So for applications, they support all 3, whereas service principals don't support federated credentials. And this, you might be thinking, well, aren't they the same? Don't you actually use service principals as the application? How do you authenticate there? Well, the portal, if you use the Azure portal, it doesn't actually show service principals having credentials. They can have credentials, especially if you work in CLIs or the API. You can add credentials and you can authenticate through them. So if you are kind of auditing your environment, don't use the Azure portal, because there might be credentials in there that you don't know about. Then we have user-assigned managed identities, which are certificate-based, 90 days valid, and rotated every 45 days by Microsoft. So that's kind of how it works behind the scenes. It's installed on the resource that you attach it to. And they support federated credentials, which is really neat. And it allows us to create a resource in Azure with this identity that you can also have federation from GitHub or stuff, which obviously proves difficult from a security perspective as well. But you can control them because they are Azure resources. You can control them with stuff like Azure Policy, which is different from service principals, which only live in Entra. And then finally, we have system-assigned managed identities, which are only certificate-based. So applications, they're called app registrations, right? But what is an app registration containing? It is a manifest that we send to Entra, which contains all these things. It contains credentials, it contains authentication information, like redirect URI, where do you want my token to be sent to once the user authenticates. We have configurations such as custom claims, if we need to customize stuff in the OAuth. We have branding options, and we have 3 specific things that I think are important to keep track of. We can create a single-tenant app, or we can create a multi-tenant app. But we can also select things here to have applications that work only for work accounts, or even consumer accounts, like my Xbox Live account, or Outlook, or Hotmail account. We have 2 options here also of selecting which kind of platform that the app should be running on. We have a public or a confidential option. This means that if we are running on a public platform, we are building an application that should work on someone's phone. We're not in control of that phone, so we can't be confident that it can store secrets, because someone could take that secret if you're installing it in the bundled code. Then it should be a public application. Whereas if we have a server on premise within our many, many layers of security, and we have some type of vault where we can store secrets confidently, then it's a confidential app. And these options depends or kind of decides which token auth flows that you have available for this application, such as device code flow or these things that you might be aware of. And then finally, the biggest thing that I think is confusing for applications is that they can be both a workload identity, which means that it can act on its own and we can give it tokens, or it can be an API, which means that we can authenticate towards this application, and we are issued a token with that application as an audience, which are 2 very different things, right? But they are the same kind of object in Entra, and they can be used, the same application can be used both ways, depending on what permissions you give it. As an example here, we have a graph for a typical interactive auth flow. We have a user down here currently running PowerShell, could be any tool. We have Entra up there, and an app registration, which we have registered maybe. To be able to call graph here, we first need to get the client ID. And if you're wondering, well, if I'm running PowerShell, I don't usually do that. That's because PowerShell has a hard-coded client ID in the tooling. Same for the Azure CLI, same for a couple of other tooling options as well. We send this request with the client ID to Entra, and it will say, first, have you consented to this application? For certain first-party Microsoft applications, those are pre-registered for us, such as Azure PowerShell, so we don't need to consent to it. It will just work. Secondly, Entra will ask us to log in to prove our identity. And then thirdly, it will give us an access token together with some other tokens we'll talk more about later. This access token is all that we need to be able to call graph, depending on the kind of permissions that we asked about here. If we specified very slim permissions, we might not be able to call graph. Also, depending on which API that we asked for a token for. Could be other APIs than Graph as well. In an OAuth term, these are called clients, authorization servers for Entra. We have a resource server. This is the real part that is kind of good to know, I think. And then the resource owner. This is the OAuth terms. But Graph being the resource server is the reason that we have resource ID, resource URL, stuff like that in the APIs for authenticating in Azure. Now, there are multiple, very many, Azure APIs here. Most of them, or all of them, are represented by GUIDs, but some of them also have URLs. If you look at Graph, for example, you might be familiar with graph.microsoft.com as the URL. This is a resource URL, but it also has a GUID, which is the resource ID. Same thing for Azure Resource Manager, but I was too lazy to get the ID. And then for Azure DevOps instead, which is an API as well that you can work with. It doesn't have a URL, it just has the ID. So you need to know that ID to authenticate and get a token for Azure DevOps. At the bottom here, I have all these slides on my GitHub at Emanuel/Swetugg Gothenburg 2024. And there's a link in a couple of these for more reading or kind of references. We also have well-known applications, such as Azure PowerShell. All of these are also represented by GUIDs, and this link has a list that is useful for log monitoring. If you're seeing like an ID in your tenant that you're not familiar with, you can see if it's a first-party application from Microsoft doing some stuff in the background, because sometimes it shows up. Azure PowerShell, for example, has this ID. If you take this and authenticate, it will just magically work because it's pre-registered in your tenant. It's great for debugging scenarios, stuff like that. Same with the Azure CLI, also pre-registered in your tenant. And then we have even other ones like Azure Portal. It's just an app doing stuff with JavaScript, and like I won't say there's no magic, there's a bit of magic, but mostly they're all applications. So it all works in the same way. Permissions then. We have Graph, we have ARM. We have a lot of different APIs and permission structures in Azure. We have Entra, for example, which is kind of part of Graph. Also container registries, its own resource in Azure, which is also key vaults, storage accounts. We have Azure DevOps on the side being its own kind of platform and API. And this just shows that there's a lot of different APIs. And some of them have the same type of permission structure. But with Microsoft Graph as an example here, an API with many APIs within, right? We have Entra ID, we have like group management and user management API, stuff like that. But we also have SharePoint and Intune for devices and privileged identity management and all these other things. And more things are added to Graph all the time, which is useful to be able to work with the same API, of course. But the permission structure is not super granular at the moment. You kind of say you have access to files or you don't have access to files. You have access to all our files in the organization or you don't from a application perspective. Applications are granted permissions. They are two different ones. They are either delegated permissions, which is a way for me to say this application can act as users that authenticate to this application from whatever permissions it has. So if this application needs to read my calendar, it needs a delegated permission, so that when I log in and consent to this application, it will be able to read whatever permissions I have in my calendar that are also common permissions with this application. Whereas if it wants to act on its own, on a timer, on a job somewhere in the background, it needs its own application permissions, because then no one is acting through it. And permissions need consent, either from the user for delegated ones or from administrators in your tenant for application permissions. Identities or groups instead in Entra, to be granted permissions. As a user, you might be familiar with like application administrator, these types of roles in Entra. So they are assigned through roles, which can be granted on groups or identities. You can add custom roles if you have P1 or P2 license, which you probably do in your organizations today. But small crux here is that workload identities, which are applications potentially, can also have roles or groups. So it's kind of complicated and it's a bit dirty, so I think we'll move on. We have ARM, Azure Resource Manager, the side of Azure where you handle the whole infrastructure side. It's all your servers, the networks, the databases, the Kubernetes clusters, whatever you work with in Azure. Your infra as code land here. And it has a different Azure RBAC structure for permissions. Role-based access control, where you have role definitions. These are what defines the permissions of a specific role. They have actions and not actions, which are basically saying that you can do this, but not this specific part. So if I say you have star/read, you have read on everything, but then I can specify stuff to exclude from that role. So I can say star/read is what you get, but you don't have star/key vault/star. So you don't get anything on the key vault resources. This is not a way to block permissions from you. You can still get those key vault permissions from another role, but it's a way for this role to be excluded specifically. They also have data actions and not data actions, which work the same way. But these are kind of defined on either the management plane, which is where you define your storage account, the security settings, the networking, versus the contents of a storage account or a database or a key vault. Those secrets, those are data actions instead. So if someone has star on the actions on the management plane, it doesn't mean that they can read your secrets. But they do have the ability to add or grant themselves roles which have that, so they still could, such as owner. They come in built-in or custom forms as well. And more Microsoft are releasing things at a pace where it seems like they're not really keen on providing a role for every single service. So a lot of the resources we see now coming out don't even have built-in roles, which means that you either get them from star permissions, like wildcard permissions, from owner or contributor roles, which are very, very privileged, or much better, you probably want to create a custom role. So to achieve least privilege, we often need to create our own custom roles. To get this assignment, to get this role and these permissions, you have role assignments, which are also resources together with everything else in Azure. They contain a scope, they contain a security principle, which could be an identity or a group, and they contain the role definition up here. For example, I could have the owner role on a specific scope for me, for my identity. Those would be the 3 parts needed for a role assignment. And when I wrote this presentation, we had about 17,000 permissions out of these 40,000, right? In this role specifically. It's like, it's everything. And that's just the data part, the action part. The data part is not included in this, so you could still grant yourself those two. Least privilege, right? The principle of least privilege, often talked about, but I find it more and more tricky to achieve in... We have a question there.
Yeah, about this privilege. On the previous slide, I mean, if you have 17,000 different, you gave yourself star actions, because what is the alternative to like have nothing and then figure out which of these 17,000 action privileges would I need to achieve what I want?
Yeah, so the question here is like, how do you achieve least privilege when this is going to work, this is going to get you everything, but how do you figure out which ones you actually need? Yeah, so Microsoft has a set of permissions, like all these 40,000 or 17,000 permissions exist as individual permissions in Azure, and you can read on docs to find them. Easiest to start with, I usually find for like, if you want to handle a specific resource type. Let's say you work with container apps. Then you find the type, the resource type, container apps, and you grant yourself star there, like container apps /star. Then you have a role that does like everything within container apps. And then if that works, you can start to look at those permissions individual and exclude or specify and say, well, this one, this looks a little bit more privileged, maybe reading secret keys and stuff within there. Those types of things might not be something that this role should do, so we try to exclude it. And it's a bit of an iterative process, and definitely could be made easier, because it's not always so so easy to achieve.
There is no other way, like do an action and you get an error message. No, you need privilege X, Y, Z, and then you could have added that to you.
Yeah, follow-up question. Is there a way, like if you fail an API call, will the error message give you any indication of which role you're missing? Sometimes, yes. I would say often you do get that, like you don't have permission on this. That's the like HTTP code, right? You get no permission. Sometimes the error says you don't have this very specific thing on this scope, and sometimes it's just like internal error. I don't know, you do your thing. Unfortunately, when it comes to least privilege, I often find that it's important to take a step back, because the more we kind of integrate our platforms, we have owner over here on a subscription scope. We can do everything there. We have application administrator in Graph or in Entra, being able to take control over an entire application or add credentials. We have project collection administrator, which is an Azure DevOps group or role, which lets them do everything in Azure DevOps. Which one is least privileged? Probably neither of these, but from like an overall perspective of everything that is integrated, it's harder to tell which one should be the right choice sometimes. If we look at an example here, we could have an Azure environment and an Azure DevOps environment. This could be your GitHub organization. It's the same deal. It's a repository and a pipeline. We have resources on our left, are some infrastructure, and then we have an identity, which is technically in Entra. But we have this identity having permissions on these resources, on that scope, to be able to deploy stuff, maybe as infrastructure as code. This Azure pipeline runs and uses this identity through a service connection and deploys these things, maybe whenever a new repository commit is added or someone pushes to the repo. This means that any developer down here can indirectly use this identity, right? Because it triggers from a repository. It also means that anyone with permissions to handle this application can handle this identity indirectly, can add a credential and authenticate through it. And it also means that platform engineers or administrators of Azure DevOps can also kind of override the security policies and settings in our repository, in our organization, to do this. So we always have to kind of take a broader look at the setup and see where do we have the weaknesses, what can we mitigate there. Preferably we want to use like privileged identity management for certain privileged roles here. Now, who can tell me what this is? It's a token. Yeah, it's a JVT, exactly. These are split into header, payload, and signature. And this is what an access token or ID token in Azure is kind of based on. They are actually just encoded bits of JSON, so they're all containing some information. This is the header, for example, which has a KID. This is the key ID that the Entra tenant signed this token with. Then you have the body with all the claims, where we can see like which application was granting, or what is the audience of this this token, for example. In this case, it's Graph. We can see what tool was used to authenticate, what application. Azure PowerShell in this case could be the Azure portal, could be something else, your own applications. And then finally, we have the signature, which is the way of verifying that this key ID is actually the signing part. So we have base 64 encoded header separated with a dot with a base 64 encoded payload, and then it's hashed and signed with this private key. And the way that all these OAuth things, I think it's interesting to have been exposed to the kind of behind the scenes thing. the way it works is that we can check the public key that the header says it was signed with. And if we're able to decrypt this and it matches our actual token, then it was signed and it's valid. All these tools do this for us, right? So we don't have to do this in our code, which is very nice. There are a few different types of tokens. We have the access token, which we talked about before. This is a bearer token because the bearer of this token can do anything. It's the only thing needed. These are used for authorization, for calling an API, and they're used for any kind of API calls within Azure or Entra or Graph or all these APIs that we talked about. It's the same standard based on OAuth 2. They are short-lived, so they only live for preferably up to an hour, and then we have to refresh them with the refresh token that we also get at our first kind of interactive authentication. There's a primary refresh token on every device that you're using for your organization, probably, if it's hybrid joined. And these are used to refresh tokens instead. So this means that if we have a token down here, since we send the access token with every API call, that could be kind of taken along the way. And that's valid for only about 60 minutes. But then we refresh it and we use another one when we need to. These also refresh themselves, so they can live for very long, and it means that they are very sensitive. They're long-lived, as mentioned, and some of them can live up to like 90 days before refreshing themselves. Then we have something called an ID token. These are used for authentication. They're to prove your identity, and they're part of OpenID Connect. This is the reason that a federated credential works, because GitHub has implemented this, and the pipeline can say, give me an ID token so I can send it to Entra and prove my identity. Entra, we have configured that if this identity over here reaches out, they can get an access token for our identity. And that's kind of how that works. Also short-lived, not as sensitive unless they belong to an identity which proving your identity for can prove troublesome and privileged. So that's a little bit about that. We have about 6 minutes. Are there any questions now before we... All right, great. So I think we have 6 minutes. No, we have 8 minutes. Is that right? Wow, perfect. So I built a module. How many here work in PowerShell at all for managing? Okay, that's more of the room than I expected. That's great. So I built a module called AC Auth, which has the ability to get all these tokens. It has support for interactive flow. It has support for device code flow, for client ID and secret for like debugging purposes. We have client certificates both for Windows where it's installed and for Linux with like a path to file. We have managed identity support if you're using it in a Azure function, for example, or a pipeline. Workload identity federation for scenarios where you have an ID token and want to authenticate with a federated credential. And we have something which I want to showcase a little bit quickly in a demo, which is called a token cache. And then some common parameters. So if we just jump here, see if, yeah, perfect. So if, can I maybe, great. So if I run just disconnect AC account, this is a command that will log me out from the Azure PowerShell module. And then I make sure to also log out from the Azure CLI. These are two tools that you work with from like a day-to-day operational standpoint or a deployment or anything with Azure. Now we have ensured that I don't have any accounts logged in, and if I get a token with get AC token from my module, it will fail because there's nothing to get tokens from. But it takes a moment because it loops through all the sources and then it checks each one of them if there are any tokens. But if I run interactive instead, I'm going to get the typical login experience here. So far, pretty simple. It's the same experience that we might have with a typical Azure CLI or Azure PowerShell experience. And then if we run it again, we can see that it's cached in the session. Now, that's very simple, but some of the good stuff here is that if I get AC token in a new session, it's not going to be there. It's not going to work again because we haven't persisted anything. It's cached in our, it was a new tab, sorry. So this one, we can close it. And it's a new PowerShell session here. So that doesn't work. So what if we connect AC account? This is the Azure PowerShell module that is provided by Microsoft. It's same experience so far. And it's going to let us, oh, sorry. I needed to select a subscription. I'll just say like 2. Great. I have logged in to Azure PowerShell. And then if I run get AC token now, it's going to actually look through all the sources on my device and it's going to get the token from Azure PowerShell because it finds it and is available. Now, that's neat. So we can use multiple sources. This also works for some other sources, and I have potential plans to add more sources such as Visual Studio Code and some stuff. But something that I want to showcase before we are out of time here is that we can also get custom caches. So I can cache my token persisted to disk using MCell. It's all built with MCell, which is the Microsoft Authentication library. In .NET, it's written in C#. All of it is open source. So you can have a look and see if you find anything that you can use for your projects. But this is actually going to allow me to get a token from a cache that I have by string, by name. This is stored on, depending on kind of the platform, like Mac, Linux, Windows, all cross-platform. It's going to store it in like a keychain or a key ring or on disk encrypted with everything. Right, we need to also say username here, because I can tab complete and find that actually found this account in that cache. And it's going to find this. And if I open a new session, I can run the same command and find it from persisted disk instead of having to like authenticate every single time. And the reason I built this is that it's like no dependencies with the Azure PowerShell and all these AC account modules and stuff. And also it allows me to use it in other modules. So I can bundle it in my small modules and I can make custom caches for that login authentication flow specifically, which I think is pretty neat. So final kind of wrap up summary. It's complicated. Unfortunately, we only had 50 minutes. I held a much longer presentation on this in 90 minutes this summer, and I felt like I could have doubled that probably. Still had to cut out stuff, and it's so much to talk about. We didn't even cover like multi-factor authentication, any user accounts really, any device stuff. So there's a lot of stuff going on. Some recommendations if you have a couple of takeaways from the talk. Don't rely on the Azure portal fully. Try to use APIs and CLIs and tooling that is fully adapted to alleviate some of that complexity. Like if you didn't know that, if you're using Azure PowerShell and you didn't know that you need a client ID to authenticate, it's because PowerShell has done a pretty good job of kind of hiding that complexity. And then finally, stop making your identities overprivileged. Thank you.